Hi, this is Glenn Mitchell. I am the Senior Lighting Specialist for Voss Lighting. I've been with Voss for the last 8 years. I want to say thank you to the team of members for your participation in the conference, and also want to say thank you to the officers and volunteers that helped make this conference a success. Today, I'm going to be talking to you about parking lot lighting and how technology can help you achieve greater energy savings and extend the life of your fixtures. First thing, do you want to replace your fixture or do you want to retrofit your lamp? We're going to talk a little bit about the differences between the two. The first major difference between a fixture replacement and a retrofit is the optics. The LED fixture is designed with optics on the lenses that help distribute the light much better than a retrofit lamp. You're going to see later on where I'll show you a distribution of a retrofit lamp and how centralized it is in the parking lot. One of the advantages to a fixture is that you can reduce fixtures. With better optics, you can spread the light out further, and when doing that, you can reduce the number of heads on a pole. In a retrofit lamp, it's only a one-for-one replacement. In a fixture, you can dim the fixture, you can control the fixture, and we'll talk a little bit more about that later. In a retrofit lamp, it's not dimmable at all. With a fixture, you get a longer life. Obviously, with a retrofit, you're going to get a shorter life, about 50,000 hours, where a fixture can be upwards of 100,000 hours. And when you look at the total cost of ownership of a fixture compared to a retrofit, you'll probably be surprised at how much you can actually save by going to a fixture. This slide, let me ask you a quick question. How many of you have seen a photometric layout? Just a curiosity there. We find that a lot of people haven't seen these before, and we're going to just talk briefly about them. This is a depiction of a parking lot with a 250 watt metal halide. And if you can see the numbers, maybe not, you're going to see that centralized around the pole, you're going to have higher what are called foot candles, which is the measurement of the light on the ground. And you're going to find that around that pole, you're going to have a higher level, and then it tends to fade out as you get further and further away from the pole. And this is a digital picture of kind of what your current parking lot would look like with a metal halide. And it just kind of gives a nice view of what you can expect on your current lighting. This slide is an LED replacement fixture. So what we're going to be doing here is, if you look around the pole, each pole, you're going to see lower light levels than you do on the metal halide fixture, but you also have an increased number as you get away from the pole a little further. You're going to see that those light levels start to stay more consistent. And when you bring it up into a digital view, you're going to see just how well your parking lot is evenly lit. That's one of the main things that we want to do in a fixture is we want your parking lot to be an even level of light. We don't want any dark spots. Bad guys tend to hide in dark spots. So we want to eliminate those. We want to provide a good, consistent light level. And we also want to avoid like high glare bomb spots. Now we're going to move on to, this is a photometric layout of the retrofit lamp. So the first thing to consider when you do a retrofit lamp is, yeah, it's great. You bypass the ballast, goes right into your fixture. That's great. It's affordable. But what it changes is that fixture, it was originally made for a metal halide lamp. So 360 light, using optics to distribute the light a little bit better. And when you get into a retrofit lamp, you're going to find that what it does, it just puts a glare bomb on the just around the pole. There's very poor distribution. And so if you can see in this photometric layout, you're going to see numbers that are high around the pole, and then they drop off dramatically as you move away from the pole. It's even worse than what you find in your metal halide lamps at times. I'll switch to the digital view, so you can see just how this retrofit lamp creates hot spots. You're going to get real bright around the fixture, and it's going to, you're going to look at it, that's bright, right? But what it does is, in between the poles, it's going to create a lot of dark spots. And anytime how your eyes work, when you're looking at something bright and then you move into an area that's a little darker, it's harder to see. And so that creates shadows, creates dark spots. It just doesn't really provide a good quality light. And then we'll look at next slide. We're going to kind of show you the comparison between a 250 watt metal halide and the LED fixture. And you can see there just how well the parking lot is lit compared to a metal halide. And then we'll compare the metal halide to the retrofit. You'll notice the hot spots are even brighter around the pole, but that makes the dark spots even darker. And I'll switch back just so you can see the difference between, if you'll focus on the right side, you'll see the difference between the LED and the retrofit lamp. So there's the LED on the right side. Switch over to the retrofit, and you'll notice quite a bit of shadowing. And in this case, you want your customers to feel safe. Your teachers, your students, after a ball game, having these dark spots provides an atmosphere that doesn't make people feel safe at times. And this is a kind of a 3D rendering of on the left is the retrofit lamp. On the right is going to be the LED fixture. And if you'll notice the increased distribution of the light, and this is how we can reduce the number of heads per pole. Say you have a pole in the middle of your parking lot and you've got 4 heads on that pole. With an LED retrofit, you're going to put in 4 lamps. But with an LED fixture, you can go with 2 fixtures and get better lighting and cut the number of heads in half. So I thought you might want to see that, kind of a nice little illustration of just how well a LED fixture is compared to the retrofit lamp. Now, guaranteed, not all LEDs are equal. Even in the fixture world, there are different levels of fixtures. You have fixtures who use optics tremendously and do a great job at distributing light. Then you have other fixtures who may use poor quality materials, not use optics. And so you'll want to, as you're investigating parking lot lighting, you'll want to look into the quality of the optics, quality of materials, so that you make sure you pick the right fixture for yourself. So we talked about retrofits and replacement fixtures. The main reason for not going with a retrofit lamp is the fact that you can't control it. So what do we mean by controls? We want to be able to dim it down. We want to be able to turn it on and off. We want to be able to use motion sensing maybe. We want to dim it down part of the evening, excuse me. We want to just be able to do things that would increase the amount of energy that we can save. And by controlling a fixture, you can also increase the life of the fixture. There are 4 basic types of controls. The first one, it's simple, just a photocell and a time clock. These are common in every school, just about, and so not a whole lot to talk about there. Automatic profile dimming. We'll move into, in coming slides, we'll talk about that. And there's infrared motion response and circuit-based and wireless gateways. Photocells and time clocks, they're simple and affordable. Newer time clocks now are astronomic. They know like where you're at in what part of the country you're in, what time zone you're in. And there's also switching for daylight savings times. And each one of you know that your engineers don't like to have to go and change all the time clocks twice a year. The biggest disadvantage to this is you're just limited to on-off only. Automatic profile dimming. This is a electronic component that is installed into a fixture. It provides flexibility towards energy saving goals while optimizing light levels during specific dark hours. When it dims down, the standard setting is 50%, and in the chart on the left, you can kind of see the duration of dimming that you can start it. The fixture, when it comes on, it will run until 9 p.m. and then it'll start dimming itself down. And then at 6 a.m., it'll run itself back up to 100% and until the fixture turns off. And there's different settings. So the number of hours that you want to dim, let's say, you want to turn it off at 11 or dim it down at 11, you can do that. It maximizes energy savings. It's standalone. There's no commissioning to go into it. It's already in the fixture. You can order it from the manufacturer. No operational costs. There's nothing for you to do. And when you pair it with a passive infrared sensor, it's added security. Let's say your police or security are driving close to the campus, and at 2 a.m., he's expecting those fixtures to be dimmed down to 50%, but he sees that they're on at 100%. Well, because of that infrared sensor, it turns the fixture on to 100%. Now he knows that something has changed. He can drive into the facility, take a closer look, and investigate a little bit. Kind of an added security measure. Infrared motion response. Generally, the light levels are set at 50% until the space is occupied. Provides energy savings. We talked about the automatic profile dimmer and the safety. There are two different types of sensors. One is mounted into the fixture, and the outboard is mounted to the pole. You can get it installed by the manufacturer. That's the typical way to do it. The one with the pole is typically done aftermarket. You would need to do that yourself. The one that's mounted to the pole generally would control every single fixture on the pole, where the sensor on the fixture would control only that fixture. Okay, circuit-based and wireless gateways. It's added controllability by grouping fixtures together. A circuit-based gateway is actually installed in the electrical room where your circuits are, and it uses circuit-based controllers to communicate with fixtures over their existing wires, issues commands to them to come on, dim down, etc. You can also tie into the internet, and you can be able to control it using an iPad or a computer. It's a way to control your fixtures by controlling the electricity. It doesn't do anything directly to the fixture itself. It just basically controls the amount of wattage going to the fixture. Wireless. Wireless is, over the last couple of years, has really increased in the technology. It uses a gateway and centralizes the controls of all the fixtures. Uses a wireless mesh network. That's something that many of you may not know about. The fixtures communicate each to another, and that's how they can link all the fixtures in your parking lot together. And it can be controlled through the internet. It can be controlled, through a tablet or a PC. The benefit to the wireless gateway is where the circuit-based is controlling all the fixtures on that circuit. So if you have half your poles on one circuit and half of your other poles on another circuit, it controls all those fixtures together in one group. So you have two circuits, two groups, where wirelessly you can control each individual fixture. And we'll get into that in a little bit. So circuit-based, you can group, like I said, you can group all of the luminaires together. You can create scenes, custom levels. You can trigger scenes based on the calendar or event. So let's say you want to schedule, every Friday night, you've got a football game or a basketball game on Tuesday. You can create schedules for yourself so that if your lights need to stay on a little longer on a certain night, then you can schedule that. And you can control it by a PC or tablet, as previously mentioned. You can also add a sensor override, which would basically turn all of the lighting on as however you set it up. In the wireless area, we talked about the mesh network. There's no wiring, no communication no cords to be run, anything like that, nothing to be done to the wiring. It communicates wirelessly, and you can do things such as monitor the status. You can log on to your account, monitor your status of all your lights, get email alerts if a fixture fails, which is great, because if you want your engineer to know, if a light's out, he can get an email for it. Remote fixture control, you can dim down, you can turn on and off any fixture individually. You can also group them together. So let's say you wanted to light, for half the night, you wanted to light up every other pole and turn the other ones off. Anything you want to do, you can get detailed usage reports, occupancy reports. Now, that's something that's interesting. If you're going to be adding in motion response to it, it can determine when somebody comes into the space, and it can tell you that, hey, this fixture came on and was triggered by an infrared sensor. One of the best things about going wireless is it is scalable under certain brands. You can scale it up to do the entire building. So you want a school that you can start in the parking lot. If you start in the school, these controls will communicate to each other, and then you can scale it up as you need. It's also BAS compatible. So depending on the type of building automated system you have, the wireless system can communicate with that, and you can control it through your BAS system. And something that's new that I haven't put on here is they have, some manufacturers have put in is now Bluetooth enabled. So instead of having this gateway, which is this white box over to the right, you can have the communication built into the fixture, and it's Bluetooth enabled. So you eliminate the need for the gateway, and you can, through Bluetooth, communicate to a fixture and change settings, do whatever you want to do. And it is still a wireless mesh. Kind of an interesting new technology that's out there right now. Kind of eliminates some of the hardware that you would need. kind of a cost savings system there. Just a couple of little things just for fun, kind of things that, try to avoid if you can. Putting multiple fixtures on a pole can be hazardous. EPA ratings on a pole are set limits, and you start adding wind sails up there, you may have a pole fall over. Definitely don't use a 2x4 to secure a pole. And in that third picture on the right, that is wall packs. Somebody has mounted 4 wall packs on a pole. We found that to be quite interesting. It doesn't really do well on distribution. Yeah, I would not put a light fixture on a fence and a security camera. Maybe a little lightning rod there. That middle picture, you see that pole standing or is leaning a little bit, and you see the fixture over to the left of the pole. We came back later, and guess what? The pole fell over. So we want to just be careful when you add things to poles. The pole is rated for a certain EPA wind rating, and you start adding weight and things that change that wind rating on a pole, you could cause serious damage. I want to thank everyone for your time and attention. At this point, we're going to take questions.
Okay. Oh my, those were fun. Okay, guys, so if you have questions, let's go ahead and you can start putting them in the chat pod. Glenn, since you have done this recording, is there anything that you want to add or anything that you want to say?
Nope, just want to thank everybody for attending. We appreciate your business, and we appreciate the time you took today.
All right, we are waiting for, does anybody have any questions about what you just saw? I feel like we should have Jeopardy music. Anything? Anybody have any comments? Anything to add? Anything that you have seen in your time at your entity, or anything else that goes along with this session? Any comments? Bueller? Well, Glenn, you know what that means? Mr. Brown, thank you. You know what that means, Glenn, is that you did a fantastic job explaining everything. It looks like Mr. Dorsman has something. Yes, I am with you, Mr. Brown. It was a very thorough presentation, very clear cut. That is what this is for. Thank you, Alvin.
Appreciate it.
And so thank you, Mr. Dorsman. I'm going to make the segue then and say, if you think of any questions for Glenn between now and tomorrow morning, go to his booth, go to Voss Lighting, click on his name. You can start up a conversation with Glenn. You can find him also through the networking section of the virtual portal. Just type in Glenn with 2 N's and he'll pop right up, and you can start a message. You guys can have a video chat. You can send messages back and forth. His email is also available if you want to send an email. Glenn, why don't you type in your email right there so that they can get a hold of you if they need to ask you any more questions about Voss or about the presentation that they saw today. Other than that, I'm going to thank you guys all so very much. if you want to go ahead and make note of his email, it is right there. But I want to thank you guys all so very much for being with us and being so patient today as we iron out so many kinks and so many other things, and dodging all the curveballs and figuring everything out, and enduring me tap dancing and backpedaling and everything else. So we just want to say thank you guys for being here. We do have a happy hour networking session here in just a little bit that will probably get started here pretty quickly. So if you have anything that you would like to discuss with other resource managers from across the state, go get on that and go get some questions answered, or just be able to connect with other people. Bring your soda, bring your coffee cup, bring whatever you want to bring, and we'll see you guys in the networking session. Other than that, Glenn, great session. Thank you so much for your time.
You're welcome.
All right, guys. Well, we will see you bright and shiny tomorrow with another full slate of all sorts of great sessions and information. And we have our exhibitor hall tomorrow. So don't forget about all of that. Take some time, go dig around the virtual site, and we will see you guys tomorrow. Bye.